Okay, we've been talking about systems of equations. System of equation is when we have two equations that we graph together and we look for the point where the two lines intersect, and that's our solution. Well, graphing isn't always the best way to do it because just our human error, we screw up the graphing and we get the wrong point, or sometimes it intersects and it just doesn't intersect at the correct, exactly on a point. It intersects somewhere in between, and we can't tell exactly where it's at. So we have substitution, and we have another process called elimination that we'll look at later. But substitution is one of the ways that we can get an exact answer every single time. Now, the idea behind substitution goes back to a dollar bill and 4 quarters. Now, our whole lives we've grown up knowing that 4 quarters equals a dollar, and we don't even question it anymore. But if you look at it, you've got these 4 coins, and they don't look anything like the $1 bill. But because we've been told that they are equal to each other, we can substitute. Anytime somebody says that's going to be a dollar, we can either give them a dollar bill or we can give them 4 quarters, and we know that they're the exact same thing. Well, that's the idea behind substitution. However, we'll be dealing with equations. So when we take a look at this equation, the first thing I want you to notice is this y. The y, it's by itself, so the y equals. And if y equals, whatever it equals is the exact same as the y itself. So y equals negative 3x minus 4. Now I know that these don't look anything alike, in the same way that a dollar bill and 4 quarters, they don't look anything alike. But if it says y equals negative 3x minus 4, then that's the same as saying a dollar equals 4 quarters. And I can substitute that negative 3x minus 4 in for any y, especially in the next equation. So if you see this next equation, I can substitute this negative 3x minus 4 in for that y, because negative 3x minus 4 is equal to y. They're the same thing. And I know the confusion is usually, well, they don't look alike. Well, in the same way that the 4 quarters don't look like the dollar, we still know that they're equal to each other. So this y is equal to negative 3x minus 4, so I can substitute it in for the y on the bottom equation. So when we do that, we're going to get negative 4x minus 2. And right here where I should be putting the y, I'm going to substitute in a negative 3x. Oops, got to do that right. Negative 3x minus 4. Put negative 3x minus 4. So I put that in for y and then finish this out is equal to 12. And you can see where we substituted in for that y right there. Now once you've done that, this is just like working out a normal equation. So we can go ahead and do our distributive property and get negative 4x plus 6x plus 8 is equal to 12. We can combine our like terms. So we'll combine negative 4x and 6x to get 2x plus 8 is equal to 12. We can then get x by itself by subtracting 8 to both sides. Those cancel. And we have 2x is equal to 4. Divide by 2. And x is equal to 2. Now, it says up top that we want to solve for both x and y. Well, that's because whenever you have a system of equations, two equations, the solution is the point where they intersect. Well, this is the x coordinate to where they intersect. Now I need to find the y coordinate. Well, if x is equal to 2, and I found that x is equal to 2, then I can substitute that 2 in for an x. Well, if I go back up to the top, I've got the y equals negative 3x minus 4. I'm going to substitute, so negative 3, instead of putting an x there, I'm going to substitute in the 2 minus 4. And so that gives us y equals -6 minus 4, and then y is equal to -10. So I'll solve for both my x and the y, and the point where these two intersect is -2, 10. 2, -10. This is the point where they intersect. All right. Now this is probably the most common type problem where you would use substitution, where you already have either x or y by itself. You can also do it with other problems. It's usually not something that we recommend that you do, but you can do it. And what we're going to do is because neither of these have an x or a y by itself, I'm going to choose, and I'm going to get this y right here in the top equation. I'm going to get that y by itself. So I'm going to come over here and write 2x minus 2y is equal to 20. And I'm going to get y by itself. So I'm going to subtract 2x from both sides. Those cancel out, give me -2y is equal to -2x plus 20. Divide everything by -2. And we end up with y equals, -2 divided by -2 would just be 1x or x. And then 20 divided by -2 would be -10. So we now have y by itself, and so y is equal to x minus 10. And I can now substitute this x minus 10 in for a y in the next equation. So I've got my next equation right over here, and I'm going to substitute that x minus 10 in for the y. So I'm going to go -4 parentheses and then x minus 10. So I substituted that x minus 10 in for the y, and then plus 3x is equal to 12. Once you substitute the x minus 10 in for the y, now we can just work this out like a normal equation. So we'll do our distributive property, and we'll get -4x plus 40 plus 3x is equal to 12. We'll combine our like terms. So -4x plus 3x would give us -1x plus 40 is equal to 12. Subtract 40 from both sides, and we get -1x is equal to a -28. Divide by -1 to get x by itself, and x is equal to 28. Now this is just our x coordinate. We got to solve for both the x and the y. So we're going to come back over. We can either plug this x equals 28 into the top equation, this bottom equation right here, or we can come back over here to where we already got y by itself and plug in x there. I think that would be the easiest. So I'm going to plug in x. So 28 in for x minus 10. And 28 minus 10 would give us y is equal to 18. So the point where these two intersect is going to be 28 and 18. And if we were to graph these, or if we were to work it out with elimination, we would still get the same answer. Like I said, I wouldn't necessarily recommend that we use substitution on this particular problem, but I also want to show you that it is something that you can use. So that's how you do substitution.